Hey guys, for this section we're going to cover exponents and surds, sometimes also called indices and powers. Those are exponents. So if you look through your notes, you can see some of the exponent laws that we have. Just to give you a quick recap of what you guys did in the earlier grades, exponents is simply something that tells you how many times you'd multiply a number by itself. So for example, 5 times 5 times 5 would give you exactly 5 to the power of 3, right? So the base says this is the number that I'm multiplying, and the exponent or the power or the index says I'm multiplying the base this many times. Okay, cool. Now let's look at some of our exponent laws, right? So in no particular order, if I have any base, for example a to the power of 0, that gives us 1, right? So the next one would then be negative exponents. So let's say I had a to the power of -1, that would give us 1 over a. So with a negative exponent, you either drop the number down to the denominator if it was the numerator, or bring it up to the numerator if it was the denominator. And then another version of this one is going to be a to the power of, let's say, -n. That's simply going to be 1 over a to the power of n, right? Simple enough. The next one we can look at would be when we take two of the same bases multiplied together. So if we said a to the power of b times a to the power of c, then we simply add the exponents. So then we get a to the power of b plus c. Let's look what happens now if I raise an exponent to another exponent. So then the next example would be, let's say, a to the power of b, and that entire thing to the power of c. That will give us, now our exponents would then be multiplied together. So that's a to the power of b times c, like so. And then let's look at now if I were to just put maybe a few of these all together, right? So if I then had, for example, I had a to the power of 2 times b to the power of 3 times a to the power of 4 times b to the power of -n, for example, right? So in this case, this base and that base are the same. This base and that base are the same, so I can add all the exponents together. Then I'm going to get a to the power of 2 plus 4 would give me 6. And then I got b to the power of 3 minus n times b to the power of 3 minus n, right? But remember, the other thing that I could do is, since I've got a negative exponent there, I can bring that down to my denominator. And then that can simply just be a to the power of 6 times b to the power of 3, because the first b to the 3 has a positive exponent, divided by b to the power of n. Now that's how you basically work through some of your exponents laws and just basically apply them simply like that. So now let's look at a few more exponent laws. So now, if I had, let's say, a number a times a number b, and they were both raised to another power, let's call that c, we then exhibit the distributive properties of exponents. And then we can simply then, the b gets its own exponent, and so does the a. So that becomes a to the power of c times b to the power of c, right? And then let's now look at an example where we divide the same base. So we had a to the power of b divided by, let's say, a to the power of c. We would then minus the exponents from the other, top minus bottom. So we get a to the power of b minus c. Now let's apply the exponent to a situation where we've got now a division sign between the two parts. So the next one, if I had a divided by b all to the power of c, we have the same distributive law as above. So we then have a to the power of c divided by b to the power of c. Now when we look at these, we can always work back and forth. So if you were given a to the c divided by b to the c, you could take that and give them a over b all to the power of c. Okay, get that in, see if it makes some sense, and then let's do an example after this. So for example number 1, okay, we would have, let's say, given half x squared to the power of 4. Now thinking back to our laws, we've got an exponent into now a whole little thing. So each of these would have to get its own exponent to the power of 4, alright? So then we have what's half to the power of 4? That's going to give us 1 over 16. X squared to the power of 4, so 2 times 4 simply becomes 8. So that's x to the power of 8. That's easy enough. Let's look at another basic example. If we're given, now again, 2x squared divided by 3y cubed, all to the exponent 3. So remember now, each of these terms gets its own exponent, right? And at the top, the 2 gets a 3, the x squared gets a 3, the 3 gets a cubed, and the y cubed gets a cubed as well. So then we can say, what's 2 cubed? That's going to give us 8. X squared to the power of 3 will give us x to the power of 6. 3 cubed would give us 27, and then y to the power of 3, and then cubed would give us y to the power of 9. Okay, that's simple enough. Let's kick it up a notch and then start doing some exponential equations. So if we're given 3 to the power x plus 1, we fix this 3, sorry, okay, minus 3 to the power x minus 1, all over 3 times 3 to the power of x minus 2. And we're meant to now simplify this and give it in simplest form. Okay, so at least the first thing I see is we've got base 3, base 3, base 3 everywhere, which makes me happy. But another thing that I'm noticing is we've got a common factor of 3 to the power of x. So let's take out the 3 to the power of x top and bottom. If I take out the 3 to the power of x here, what I'm left with is 3 to the power of 1. Minus, then I take out 3 to the power of x here, I'm left with 3 to the power of negative 1. Okay, and at the bottom, if I take out a 3 to the power of x, I'm left with 3 to the power of 1 times 3 to the power of negative 2, which is going to be 1 plus negative 2 gives us the negative 1. 3 to the power of negative 1 after having taken out our 3 to the power of x. Now we can simply cancel out 3 to the power of x, and what we have left are just numbers that we can evaluate and find an answer for. That's going to be basically 3 minus a third at the top divided by a third. And obviously when we divide by a third, the same thing as multiplying through by 3, right? So then 3 times 3 is 9. And then 1 over 3 times 3 is simply 1. But a negative 1 because that 1 there, negative 1. And then our final answer is 8. Simple enough. Let's try now an exponential equation. So let's say we're given 3 times 2 to the power of x plus 2 to the power of x minus 2, and that equals 26. Now the whole point of exponential equations is to try and get the bases all the same so that we can then equate the exponents. So now we've got 3 times 2 to the x, 2 to the x, and a minus 2 there, and that's 26. So as it stands, nothing really jumps out at us in terms of how we can basically go about solving this thing. But let's try and play around with the numbers and see what we end up with. So if I've got 3 times 2 to the x there, plus, that's going to be 2 to the negative 2 times 2 to the x there, and that's going to be equal to 26. Then what we can see is the common factor of 2 to the x is here. We can take that out and be left with just numbers. So then I take out a 2 to the x, I'm left with 3 plus 2 to the negative 2, that's equal to 26. And if I divide through by this term, I can leave my 2 to the x just as it is. So then I've got 2 to the x, and that's going to be equal to now, let's see what this is. 3 plus 2 to the negative 2, that's a quarter, so it's 3 1/4. Let's try to put that in improper fraction form. So if we have, let me just put a sidebar here. So that's 3 1/4. So 3 times 4 is 12 plus 1 is 13 over 4. So if we're going to now divide by 13 over 4, so 26 divided by 13 over 4, we just tip in times, right? So we're going to get 26 times 4 over 13, and that sort of looks a lot better. 26 goes into 13 twice, so that can cancel out, and this becomes 2. 2 times 4 is simply 8. So 2 to the x is equal to 8, and we can rewrite 8 as 2 to the power of 3. So 2 to the x is equal to 2 to the power of 3. Therefore, equal bases, I can equate my exponents. We end up with x being equal to 3. And that's a nice example of how we can simplify exponents as well as work with exponential equations. Okay, now let's go look at some third examples.